I'm going to talk about the insight and the foresight on products that we believe that IoT is providing that will radically and is radically transforming industries and enabling new industries. I'm also going to talk about a case study of our work as well. And if I run out of time, I'm going a little bit slow today because I've got woman flu. I will stop where I stop. That's slightly cheating. Okay. So we are hugely excited about things being connected to the internet and sending data. For the first time in human history, everyday products are able to send data about themselves, are able to talk about themselves. This is radically different to the last 250 years of industrial economy output, which is based on a cycle of make, sell, dispose, and repeat of that, with very little knowledge about that product through that process. This data from products will change the way that products are made to begin with, how products are used, where in the value chain value is captured, and how we deal with the so-called end of life of products. We believe that the Internet of Things will result in more closed-loop production and, in the end, radical dematerialization of economies, where a connection to the thing that provides a service to an end customer becomes as important to us as the thing as itself. As well as changing the make, sell, and dispose economic model, products will radically shift how value is captured. For instance, when we know how well something is working, or if it's not working well, the service model to support that thing becomes equally as important as the one-time sale of that thing. Or, if we lease something as opposed to selling it, there becomes a dependency on that thing working. So, we believe that product intelligence and how we interpret or how we describe product intelligence is insight translated from data will play a transformative role through the supply chain. And if you don't know this model, this is the circular economy model that looks at ways of extending product life as well as retrieving materials in a supply chain. Our vision at Product Health is for longer and healthier lives for powered products. To achieve this, we sell actionable intelligence as a low-cost service to manufacturers and distributors. And our market, certainly at the moment, is the stationary and traction battery market. So we are capturing data on lead-acid and lithium-ion batteries, and we are translating that data. We're deriving insights about the health of batteries in advance of them failing for that sector, as well as enabling remote control of batteries and understanding all the time how those batteries are being used. And I'll get to the case study of our work later. We offer an end-to-end solution that, in effect, starts with some monitoring hardware. And our aim with our monitoring hardware that we call our monitoring kit is to be radically cheaper in the market than what's existing. So in the battery market at the moment, there is some degree of battery monitoring going on, but it's a very expensive piece of hardware, and there's not an easy interface to that data for an end customer or for somebody who's servicing that battery. So we sell our monitoring kit, which includes a very low-cost battery sensor and a comms hub that sends raw voltage, current, and temperature data to our time series database in the cloud, where we run our secret sauce, which is our algorithms, to analyze the data and derive all sorts of insights about the state of health of that battery that we're connected to, such as state of charge, an estimation of battery capacity, which tells us how well that battery is doing and if that battery is healthy or if it's getting into trouble, if it's overheating, if it's just looking different to a group of others that are in the same area where there's the same amount of sun coming in from panels, for example, or the same temperature outside. And we can do things like detect devices, so we can see what customers are using their batteries for. We provide access to this type of insight through a dashboard interface where you can also configure your own alerts and notifications. So there's no point having this data unless we can act on this data. So we provide the mechanism, the tools for people to know in advance every day if one of their batteries is failing, or if it looks like one of their batteries is coming to the end of its life, or one of the batteries in a bank of batteries is getting into trouble and that would need retrieving. Our hypothesis is that by having access to intelligence on products, people can make valuable decisions that lead ultimately to better performing products, reducing failure, extending the life of products, as well as reducing redundancy, both from the supply chain, so preventing faulty products even being shipped to begin with, or meeting or reaching the market and an end consumer, so there's no need to retrieve and to ship the product back and to fix it. Or designing much better fit-for-purpose products because we've learned from that product, and a battery is a good example. There's quite a lot of guesswork that goes into sizing of batteries in an off-grid solar installation or for backup power, and often there's a lot of guesswork about when that battery's come to the end of its life, so there's quite a lot of waste in the system. And then a continuous connection to the product, which ultimately means a continuous connection to the person using the product. And that can enable all sorts of different things. So a connection to a product means we can turn it on and off, which means we can rent it or offer a payment plan around that product. We can also get quite close to the end customer and learn about their behaviors and their needs and understand if they might need bigger batteries or when they would need a new battery. Our market is, as I said, it's the stationary, so that is things like backup power batteries. In developing economies, most ATMs would have a battery behind it because the grid connection isn't reliable. As example, telecom towers have battery power to support them, so if the power goes down, the telcos still work. Batteries are used in airports. This is more the traction market in marine, and for things like machinery, heavy machinery. So, in summary, the problem, the macro problem we are solving splits into two areas. One is that we feel that we've reached the limits to our make, dispose, and sell economy, where products, we've reached a point where products are sort of sold as commodities like boilers. We have no idea how they work, and we have no idea what to do when they fail. Business models are designed in a linear way which don't necessarily meet the needs of growing populations heading towards 9 billion people by 2050, and it's resulting in a lot of waste. The second problem, or problem opportunity, is that there are new markets that wholly depend on products being connected or devices being connected. And this is a product in the off-grid power market in developing countries. This is what's called a solar home system kit. It includes a battery, a panel, and a series of devices. You can't easily sell this product to rural low-income communities without offering some kind of ability to pay for it over the long term, so a payment plan or a pay-as-you-go technology. You can't easily do that without removing the risks, without some connection to that product, which means that you can turn it off if somebody isn't paying for it. You can't also easily do that in remote rural villages in the middle of nowhere without having the ability to check that those products are working, to preempt problems with the product, and to prevent problems, to prevent misuse of that problems, and to evaluate how those products are working. If they don't work, customers will also not pay. So let's just talk about us for a minute. We started here way back 2.5 years ago with a big question around how we improve and extend the life of batteries and what goes on inside a battery. Batteries have been around for a long time. There hasn't been a huge amount of innovation around lead-acid batteries, so we were exploring that question. And we explored that question in collaboration with the University of Oxford, a team at the University of Oxford from the Power and Engineering Group and the Machine Learning team. And we continue to work with them around this problem. They introduced us to our customer, who's actually here today, a company called Bbox, who are a manufacturer of solar home systems, much like I introduced earlier, with the very same problems. So they need to sell their product with a long-term payment plan. They have a huge market opportunity, 1.3 billion people without access to grid power. They also need to maintain their products remotely, and that is a big challenge. And then our evolving market opportunity, as I said, is the wider battery market. So lead-acid and lithium-ion batteries used for all sorts of use cases where there's a critical need for those batteries to be working. That's where we come into play. And this is why we offer what we're offering. This is the problems that we are solving. So batteries typically fail. I've talked about this. Failure is expensive. They sometimes fail because they're being misused, so there's an opportunity to prevent misuse. They reach the end of their life, and it's not always obvious when they're going to reach the end of their life, despite what a manufacturer might say. It's much more to do with the number of cycles a battery goes through. Service call-outs, so if you don't have a connection to your battery, service call-outs are pretty impossible to qualify. How do you know what's going on with that battery if there's no connection to it? So that can be expensive. And then what has happened to the history of that battery is very difficult to evaluate. So a customer may tell you they did X, Y, and Z, but typically they've used, twice as much as they set out to use to begin with. I've talked about business models that depend on products working in a battery in the context of the solar home system market needs to work, and business models that depend on a remote connection. And then the conversation that nobody's really having, the big elephant in the room, which is what happens to the end of life, at the end of life of a lead-acid battery. Oh, it's a bit blurry. This is some dummy data, but shows you our dashboard. This is raw data, voltage, current, and temperature data on batteries generated from our lab environment. And this shows the algorithm that we've developed, our battery capacity estimation algorithm, which can clearly show you which battery is getting into trouble here. So we can use that to inform us in advance. And we're just working on a predictive version of us, which will give us more runway on that green line dropping off. Just to prove that we're not the only ones in the world looking at this idea of maintaining products, extending the life of products, and reducing redundancy in products. Tedo, who are the Nest, the German version of Nest, are not only measuring energy consumption, but also offer, it's actually a free service where they do a boiler check once a year just before the winter to their customers. Heavy goods equipment has been monitored for a while. They have 24-hour service centers responding in advance if the components of this material, if components of this machinery are failing. We've recently talked to a high-end manufacturer of tools who wants to do a similar thing. And then more recently, Siemens have launched their iSensoric, I think it's called, washing machine, which the motivations are largely around efficiency of an intelligent washing machine. At the moment, I don't know if there's any interface with customer or anyone else to know if that washing machine is failing, but it's certainly performing better and reducing redundancy in its performance. And our future, I've got 1 minute, 27 seconds to talk about our future. As I said, we want our monitoring hardware to be disruptively cheaper in the battery market so that we can make this type of service available to more and more of the market. Ultimately, we are also dematerializing within that market, so we're taking the kind of old school version of battery monitoring, which would have a kind of Honeywell type meter by the battery. We're taking that out and we're making our data mobile. Smart, connected, and healthy products. We're starting with batteries, but we see an opportunity to bring this type of hardware and service proposition to all sorts of powered products in the future. And we see ourselves as predicting the future. We have foresight on what is happening to products. And this is just a call to action. So if there's any battery manufacturers or distributors or anybody playing with batteries in the audience, we are really interested in talking to you. We're doing some very groundbreaking research, which is being supported by the UK government, on predictive analytics, predictive health analytics. And I'll stop there.
Tamara, thank you very much. Really interesting stuff. Thank you very much for sharing that. My background in the IT industry is about systems management, where we would deploy an infrastructure that would monitor software, bits of hardware in the server infrastructure and so on. And when, for example, a battery on a motherboard was going, a little alert would come up, someone would replace that. Or when, a process was, consuming too much RAM or whatever else. In a way, what you were just talking about is systems management, but on a physical level. You're talking about devices in the middle of Africa, solar panels, batteries as well, being able to measure that, monitoring it, and provide an action, which is great.
Yeah. We're also addressing a sort of middle market. So this stuff has been going on for a while. We know that most components inside aeroplanes are monitored, oil rigs are monitored. Typically, very high-end, high-value assets have been doing this for a while. We are bringing this to a different level or different layer within a market opportunity, and in particular within the battery market.
Beyond batteries, I mean, batteries absolutely looks like a very strong case for what you're doing. Are there other components beyond batteries that you can see this model applying to at scale that you're talking about?
Yeah, I mean, we've had a lot of interest from the distributed water market, so boreholes, water infrastructure, sanitation, again, largely in emerging economies and developing economies. But, water is something that needs to be managed, is typically poorly managed. There are, like off-grid power, there is poor access to water for, billions of people on the planet. So I think water is the next obvious one. And then I think another area which actually, quite surprisingly to me, has quite a lot of parallels in terms of the needs are things like tools, sort of high-end or slightly more high-end manufacturing tool, sort of DIY tools, saws and drills, and quite expensive kit where very similar to a battery, it depends on the life of it, will depend on how many cycles it's done.
Sure.
There are opportunities to servicize the business model, learn how customers are using it, evolve the product according to what the data is sending back, alert when something goes wrong with a component of that machinery.
I like the kind of building a service model around what you're doing with Internet of Things with regards to measuring and monitoring. I guess part of that depends upon manufacturers' willingness or ability, but willingness to modularize their products so that you can whip out and replace a battery or whip out and replace a blade or whatever other thing you're monitoring.
Yeah, and I think in the short term, we won't necessarily work directly with the battery manufacturers. There typically has to be a service component involved for this to really add value. And so it's more the installers and integrators, and in the end customers, where we will initially add value.
Finally, just for my points, and we'll go to the floor, Tardo. I've actually got a Tardo at home. This is the boiling smart...
That's how you pronounce it.
Tardo, yes, it is Tardo, German company, Tardo. And then you talk about an internet-connected fridge. I mean, really, we're going back to Hugh. You know where I'm going here. Internet-connected fridge, internet-connected boiler, washing machine. Actually, it does begin to make sense when you've got replaceable components. So you're not having to replace the whole white good in your room, in your kitchen. You can just replace that little, whatever the bit of technology in a fridge is. Sorry, I don't work in that area.
The clue, I think, though, there is in the business model. So at the moment, we still all buy a washing machine and a fridge. And it's we don't necessarily have to buy a washing machine and a fridge. And also the value of the data. So there's a value of the data to the product asset, but that data is also valuable to the energy companies. So
absolutely,
that begins to change things, which comes into my statement at the beginning, which was radical transformation of industries.
Yeah, excellent. Thank you very much, Tamara. Any questions from the floor? Very quick hand over here. George is coming to you very quickly.
Matthew Fox of the Connected Home Consortium. I just wanted to ask how far, you talk about being in the middle market, how far is this from getting to a retail consumer market? I represent social landlords, and clearly we have carbon monoxide sensors, other sensors in the homes. We have pumps that have backup batteries, which if they don't work, mean the home could flood. There's a whole range of things that depend on smaller batteries than you're talking about, but which nevertheless one does need to know when they're coming to the end of their life.
Yeah, we need to talk. Yeah, I mean, there's a sort of energy challenge with it, a power draw challenge. So the sensor in itself and the comms module will use an element of power, but if that can be powered by a different source, there's obviously the economics around it, so the cost of the sensor and the GSM module. But I think, yeah, over time, those costs will come down, and over time, you know, we would want this to reach the consumables and the consumer market. I mean, we see what we're doing with our hardware reaching a consumer market. And at the moment, monitoring of batteries isn't very accessible to consumers. So, yes, certainly, you know, we'd like to be reaching consumers in the longer term. But it's how this stuff trickles through a market and where that market is at in terms of its sophistication. And what we all know is that it's relatively early days.
Terrific. Thank you very much. Yes, you two, go and have a chat right now. Unfortunately, it's time to move on for now. But for now, please give it up for Tamara.